So till now you probably must be thinking that we are going to deal with a lot of applied things. But let me give you a definition right now that will make you feel that you are doing mathematics and a lot of analysis, right? So let me give you this definition first, okay? So what can we conclude about probability? So probability of A occurring A is nothing but the cardinality of A divided by the cardinality of sample space. This is the thing you know, right? But you also know A is a subset of S. The worst case that is happening is A will be equal to S, and the least case that is possible that is A will be equal to phi, right? These are the two cases. Okay, so cardinality of A is in between. Empty sets cardinality is 0, okay, and S cardinality. Okay, this is the possibility that we are concluding. Suppose we divide S throughout. So A divided by the cardinality of S, which is cardinality of S upon cardinality of S, that is obviously 1. So 0 is less than equal to probability of A's occurrence, and which is always less than 1. So the thing that you concluded is probability of A, this will always belong to 0 and 1. So this is a definition that probability is a function that takes a set, okay? A is a set, right? So that takes a set, say M, a set M to the interval 0, 1. Okay, this must be clear. Okay, what is M? M is nothing but all the sets that are possible. Okay, all the sets that are possible to be subset of S, that is nothing but the power set of S, not the probability. Okay, this is the power set of S. Okay, power set of S. What are the power set of 1, 2 and 3? The power sets of this is phi, singleton 1, singleton 2, singleton 3, 1, 2, the set 1, 3, the set 1, 2, 3, and the set 1, 2, 3 already ignored. So this is the sample space, right? So what is the definition of probability right now? Probability is a function that maps some set M, which is the power set of the sample space, to the interval 0, 1. Okay.